So in this problem, we have a roller coaster that's starting from rest at point A. And then we want to find the speed of the car at the bottom of the hill. Okay, so we're looking for a velocity. So they haven't given us that much. They've given us that our height is 140 meters and we started at rest. If we start at rest, your kinetic energy before is equal to 0. So our energy before will only be equal to potential energy. Remember, potential energy has to do with height, and so we're up high, but we're not moving, so we'll only have potential energy. Potential energy is equal to mass times gravity times height. Our mass, we don't know. That's okay. We'll get rid of it later. Gravity we know because we memorized it. I told you you'd use it a lot. And our height we know because that's on our roller coaster. And so we'll end up with 1372 m. That's okay. Leave the m. I know it freaks you out, but it's okay. You can leave it. And then we know that the energy after, or at the bottom of the hill, is equal to the energy before. And since we're at the very bottom, after, our energy after is just equal to kinetic energy and no potential. So our energy before is 1372 meters. Our energy after is just kinetic energy, which is 1/2 mv squared. If you multiply both sides by 2, you can get rid of the 1/2. And you have 2744 meters. Or 2744 m, sorry. And then you have mv squared. Now we can divide both sides by m, and we can get rid of that pesky m that we didn't know, and I told you we'd get rid of it. Now you have 2744 equals v squared. You can take the square root of both sides, and you'll end up with 5238 meters per second as your velocity at the bottom of the hill. So it's a couple steps, and it requires you to actually know and think about things, but it's not too bad. In part B, it says, what is the speed of the car at the top of hill B? Now, we know that our energy before, which is the energy right here, was 1372 m. And our E after, or at point B, we're going to have some potential energy because it's not on the ground, but we're also going to have some kinetic energy because it's moving. And we also know that our energy before is equal to our energy after. So we have 1372 m is equal to mgh, which is your potential energy, plus 1/2 mv squared. Now I'm going to plug in my numbers. I'm going to multiply these two together I'm going to get 931 m plus 1/2 mv squared. I'm going to subtract 931 m from both sides. End up with 441 m equals 1/2 mv squared. I'm going to multiply both sides by 2 to get rid of that 1/2, which will give me 882 m equals mv squared. I can get rid of my m because it's on both sides, so I'll divide both sides by m. Then I'll have 882 equals v squared. I'm going to divide both sides, or take the square root of both sides, and I'm going to get 29.7 meters per second, and that's my speed at the top of hill 2. If you want, you can try and see if you can find the speed at C, just for something to do. It works the same way.